Hello everyone, welcome to my YouTube channel School of Chemistry. Today we are going to study various methods for the preparation of alcohols. So we will be studying methods of preparation of alcohols. In order to prepare alcohol, first method which we can use is from alkenes. Now we can have two methods to prepare alcohol from alkene. One is by acidic hydration of alkenes. Let us take an example. So over here we'll be taking ethene CH2 double bond CH2 and reacting it with water in presence of concentrated H2SO4. So the water gets added in such a way that we get CH2OH over here. If we have an unsymmetric alkene, that is CH3, CH double bond CH2, and we are going to add water it in, then also we will be using concentrated H2SO4, leading to the formation of secondary alcohol, and the addition of water is taking place by Markovnikov addition. That is, negative part of the reagent get attached to that carbon of the double bond which has lesser number of hydrogen atoms on it. Second method for the preparation of alcohol from alkenes is by hydroboration oxidation. In this method, we will be taking an unsymmetric alkene. Let us start our reaction with propene CH3 CH double bond CH2 and first react it with BH3 for the process of hydroboration. So how BH3 is going to add into it? It will be adding like this. We can write BH3 like this. So from here this double bond gets broken down. From here the cleavage of the boron hydrogen bond takes place and the addition of hydrogen will be there on this CH and BH2 on this CH2. So this will be adding as CH3, CH2, CH2, and then we have BH2. Now we have two more hydrogens present on this boron. So first let us react one more molecule of the alkene with it, and similarly we can have CH3, CH2, CH2 whole twice BH. Now we are left with one more hydrogen on the boron, so we can add one more alkene into it. CH3, CH double bond CH2, and similar way the addition will take place, leads to the formation of CH3, CH2, CH2 whole thrice and the boron. This is hydroboration. Next step is the oxidation, which is carried out by using hydrogen peroxide, that is H2O2. So in this reaction we will be requiring 3 molecules of H2O2 which reacts with this compound and leads to the formation of 3 molecules of the alcohol CH3, CH2, CH2OH plus the side product boric acid BOH whole thrice, or we can write it as H3BO3. Okay, if we look on the initial reactant and the final product, it appears that we have added H2O into it, and that is by following anti-Markovnikov addition. So whenever we need to synthesize an alcohol from an alkene that appears to be the addition of water by anti-Markovnikov addition, then we need to follow this method, that is hydroboration oxidation, and we get the respective alcohol. Next method for the preparation of alcohol is from carbonyl compounds. So carbonyl compounds will be the compounds containing the C double bond O group in them. Okay. So this include, first part is from aldehydes and ketones. Aldehydes and ketones. We have aldehyde as RCHO. This is the general formula of the aldehyde. So aldehyde can be easily reduced to the respective alcohol by using the weak reducing agent like sodium borohydride, NaBH4. So it can be converted into RCH2OH. And we can even use lithium aluminum hydride, but that is quite expensive. And if we have the ketone, then in that also we can use sodium borohydride, BH4. But in case of ketone, we will be getting a secondary alcohol, and in aldehydes we will be getting primary alcohol. That is only the difference. This is a primary alcohol 1 degree, and this one is a secondary alcohol 2 degree. That's the only difference in the reduction of aldehyde and ketones. And always remember NaBH4. This is a weak reducing agent. So it can be used only in the case of aldehyde and ketones. This can't be used to reduce carboxylic acid, esters or acid chloride. Or you can say we cannot reduce any of the acid derivative using the sodium borohydride. Now the next method is from carboxylic acids and esters. So carboxylic acid, we can write down the general formula as RC double bond OH. This is the general formula of the carboxylic acid. In order to reduce the carboxylic acid, we will be requiring strong reducing agent like lithium aluminum hydride. We can't use sodium borohydride in this case, that is a weak reducing agent that can only reduce aldehyde and ketones. So we will be requiring lithium aluminum hydride in order to reduce carboxylic acid, and the resultant product we will be getting is an alcohol, that is a primary alcohol. This lithium aluminum hydride is quite expensive. So in order to make this process a little cheaper, we can first convert this carboxylic acid into an ester by reacting it with an alcohol. So in acidic conditions, if we first treat this carboxylic acid with an alcohol, this lead to the formation of RCOO R dash. This is an ester with an elimination of water. After that, this acid is reduced with H2 in presence of catalyst, and we will get the respective alcohol plus R dash OH. We get this mixture of alcohols, the alcohol which are used to convert the carboxylic acid into ester plus the reduction product of the carboxylic acid. So it is a cheaper method of converting our esters into alcohol. Now the third method is by using Grignard reagent. Using Grignard's reagent. As you people are all aware about this reagent, Grignard reagent, we have studied about it in the first chapter, that is haloalkane and haloarenes also. The general formula is RMGX of the Grignard reagent. So the beauty of this reaction is that whenever we react, let me first write down the general reaction. Let us take a Grignard reagent and react it with formaldehyde. This is the formaldehyde. So we know that the alkyl group is slightly partial negative charge and this is partial positive charge. So the attack will be there on this carbon and on this oxygen, as the cleavage of the multiple bond will be there. So it leads to the formation of or addition product of OMG X, and R is going to attach on this carbon, followed by hydrolysis. In acidic conditions, we will get RCH2OH. Over here, we will be getting the primary alcohol plus MgOH and X. Suppose we have any other aldehyde except this formaldehyde. Let it be suppose R dash C double bond OH. Now in that case the addition product form would be R dash C O MgX. Over here is the hydrogen, over here is the other alkyl group which comes from the Grignard reagent, and then if we add water into it in acidic conditions, the cleavage of this addition product lead to the formation of R dash CHOH, and we have alkyl group plus MgOHX as a side product. So over here we will be getting secondary alcohol, and if we react this Grignard reagent RMGX with any of the ketone, that is R dash C double bond O R double dash. Suppose this is a ketone, then the addition product form would be OMGX R double dash over here, and over here is the R. So followed by hydrolysis H2. In acidic conditions, we will be getting R dash C OH R double dash, and over is the R plus the side product MgOHX. Okay, and this one is our 3 degree or the tertiary alcohol. So these are the method of preparation of alcohols from different reagents. So let us recapitulate what we have studied today. We have studied the method of preparation of alcohol. First, we have studied from alkenes. From alkenes, we have two methods, that is by acidic hydration of alkenes, that we can do by adding water into the in presence of concentrated H2SO4. Okay, and if it's a symmetrical alkene, need not to worry, you can add hydrogen on any side and OH on the other side. But if the alkene is unsymmetric, we have to take care of the addition by following the Markovnikov addition. Next is the hydroboration oxidation. In hydroboration oxidation, we will be taking an unsymmetric alkene in which we will be adding BH3, and the addition takes place simply by the cleavage of a multiple bond. Hydrogen gets added to the you can say second carbon and the BH2 to the terminal carbon with the addition of two more alkenes to this. So that's the addition product, 3-alkyl boron. Okay, and hydrolysis is done or the oxidation is done by using hydrogen peroxide. We get the respective alcohol plus you can say boric acid or H3BO3. Next method is from carbonyl compound. From carbonyl compound we have two you can say further methods. First one is from aldehyde and ketone. In aldehyde and ketone, we can use sodium borohydride, which is the weak reducing agent that can reduce our aldehyde and ketone to the respective alcohol. If we have aldehyde, we'll get primary alcohol. If we have ketone, we get the secondary alcohol. From carboxylic acid, we cannot use sodium borohydride because that's a weak reducing agent. So in carboxylic acid, we will be using lithium aluminum hydride. It's a strong reducing agent and can easily reduce carboxylic acid to the respective alcohol. But the method we are adopting over here is quite expensive because the catalyst over here is quite expensive, which is lithium aluminum hydride. So in order to reduce the cost, we can first convert the carboxylic acid into the respective ester and then catalytically reduce it by using H2 in presence of any catalyst. Next method is by using Grignard reagent, that is RMGX. We can add Grignard reagent to formaldehyde to form the addition product. Followed by hydrolysis, we get primary alcohol. If we add Grignard reagent into any other aldehyde except formaldehyde, we get the secondary alcohol. And if we add this Grignard reagent to a ketone, then the hydrolysis of the addition product gives us the tertiary alcohol. Hope my videos are helping you in your studies. So for more interesting video, please like and subscribe to my YouTube channel School of Chemistry. And in next video, I am going to explain the mechanism of the first reaction which we have studied today, that is acidic hydration of alkene. Thank you all.